All right, we're looking at 7.2 now, multiplying and dividing polynomials. So above, we added and subtracted. That was what example 3 was, right? Part A was adding, part B was subtracting. And we talked about how the fact that they were closed, right? If you added two polynomials, you got another polynomial. And if you subtracted two of them, you got another polynomial. So here, we are multiplying and dividing. When we multiply, we're going to get another polynomial. When we divide, we might get another polynomial, right? In dividing, think about the integers again. We talked about integers in the last video. If you take 8 divided by 2, you get 4, right? 8, 2, and 4 are all three integers, right? So that one, it worked out. But if you take 8 divided by 3, well, that doesn't give you a nice integer, right? This right there is not closed, right? It is open, right? It expands into the decimals. So that idea is the same idea that we use kind of here to say that polynomials are not closed on division, but they are on multiplication, right? You take 2, right? You take 8 times 2, you get 16. You take 8 times 3, and what's that? Is that 24? Right? Both of these, you multiply them, and you get another integer. So they're closed. All right, looking here. Example 6, we have we have a monomial and then a binomial, right? We're multiplying them. We're just going to distribute to get a new piece. So I'm going to take the 4x times 3x. 4 times 3 is 12. X times x is x squared. And then 4x times negative 6 is going to be what? Negative 24x. And there we be. That's it. We started off with two polynomials. We ended with a polynomial. Scrolling down, here we have a monomial and a trinomial. So I'm going to start off by distributing this guy. Negative 2 times 3 is negative 6. X cubed times x squared is x to the 5th, right? We're adding those exponents. Next up, we're going to have negative 8 x to the 4th. And then lastly, positive 14 x cubed. All right, nothing crazy there. Example 8. Here we have a binomial and a binomial. And in the parentheses there, I say that I want us to use a table. Now, there's different ways to do it. The common ways that people reference are using a table and then foiling. I prefer the FOIL method. I prefer it's just kind of like fancy distributing. But the table can be useful too. So I want to show you that. So if you've done Punnett squares in science, this kind of reminds me of those. So we have x plus 4 on one of them. And then we have 2x minus 5 on the other. And I'm making this into a little table here. Now, in each of these, just like a multiplication table that we've done before, you multiply the pieces. So in the upper left corner, we're going to take the 2x times x to give us 2x squared. Next to it will be, what is that going to be? 8x. This will be negative 5x and negative 20. Okay, so just to reiterate, this negative 20 came from multiplying this guy and this guy. This 8x came from multiplying the 4 and the 2x. Okay, now that we have our four pieces, we add them up. And we look, and we're wanting to put them in standard form still. So the highest exponent is 2, so we'll have 2x squared. That's the upper left piece. And then the two middle pieces, these two kind of on the diagonal, we can sum those to get, what is that, 5, 6, 7, 8, so plus 3x. And then lastly, we have the negative 20. All right, there we be. Something to make note of, something to notice. Our first two, there was no combining like terms at the end of it, right? This one here, we did have to combine some like terms to get this middle guy, right? 3x was not listed over here. We had to take the negative 5 and the 8 and put those together, okay? Whenever you've just got a monomial here and you're multiplying by it, oftentimes you don't have to combine like terms at the end. Whenever you have a binomial or more, you normally have to combine like terms after multiplying. All right, that is that. Example 9. So this is using FOIL, and FOIL stands for first outer, inner, last. Now the way that you can memorize that, you can use that if you want to, but I always think about just fancy distributing, right? We know how to distribute, and now we're just going to have to distribute more than once. So I start off with my 2x. He distributes to the x and to the negative 5. So that'll be 2x squared minus 10x, right? That's just taking care of my first term. Now I've distributed my first term as much as I can. So I move on to my second one, my negative 1. And I distribute him to the x and to the negative 5. So that'll be a negative x and then plus 5. Okay. Now I've exhausted both of my terms, right? I've distributed as much as I can, and I go to combine like terms. We see the middle piece. These can combine, and I'll have 2x squared minus 11x plus 5, right? This negative 1x right there gives me the negative 11. And there's my new polynomial. All right, so there we took, I don't know if I said this yet, but we had a binomial and a binomial. We multiplied them, and we got a trinomial. So that's kind of neat. We want to still be trying to remember those words there. Next page. Here we can multiply them however we want. If you want to use a table, that's awesome. I'm going to do them in the way that I did example 9 there. So I'm going to multiply 2x times x to give me 2x squared. 2x times negative 1 to give me negative 2x. Negative 3 times x, negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. Combining these middle pieces, I'm going to be left with 2x squared minus 5x plus 3. And there we are, we're done. All right. All that we've been doing, these are all multiplying, right? Hopefully that's kind of obvious that we're multiplying. Now right here, we're going to be dividing. And dividing is a little bit funky. It's a little bit different. We have our trinomial on top and our monomial on bottom. And what we're going to do is we're going to try to factor the top of it and see if anything can cancel. Okay, so if we think about taking like 10 divided by 5, right? We can straight up divide those if we want, but let's kind of break that apart and think about what happens. We can take the 10 and we can say that he is 2 times 5. Ooh, this is an equal sign. And then the 5's on bottom. Then the 5's cancel and we're left with 2. Okay, that idea there with the 5's canceling, that's what we're going to try to do here. So I look at my denominator, I see it's an x cubed. So I'm going to try to factor out an x cubed out of the top. Right, and factoring is just undoing the distributive property. So in my first term, 2x to the 5th, if I undo distribute an x cubed, I'd be left with 2x squared. Right, and I can check myself. If I distribute that back, I'd be back with an exponent of 5, so I'm good. Next up, I do the same thing with my next piece. Maybe let's use a different color than blue, maybe green. If I take away 3 exponents, I'd be left with plus 3x, just a plain old 3x. And then lastly, I'd be left with just a plain old 8. In my denominator, I still have an x cubed. Now I can see that I have an x cubed and an x cubed. They can cancel. And I'm left with that piece in parentheses. 2x squared plus 3x plus 8. There we be. So right there, we divided 2 polynomials, right? The top one was a trinomial, and we divided by a monomial. And we actually got another polynomial, right? Our result right here, that is a polynomial. So if we look back up at the very top there, where was it? Right here. I was talking about 8 divided by 2 gives us 4, right? This one works out very nicely, okay? I want us to recognize, though, that sometimes they don't work out nicely. Sometimes they can't factor nicely, right? On the one down here, it just so happened that the x cubes canceled out perfectly, okay? If they didn't cancel out perfectly, we might be able to still cancel some things out and reduce, but we might still be left with a denominator, and that means that it wouldn't actually be a polynomial, okay? So that one there, that one worked out very nicely for us. Example 12. I'm looking here, and my denominator here is a y minus 6. So I'm going to try to factor the top to make it look like a y minus 6. So I see that both of these in the numerator I could divide by 4. So I'm going to pull a 4 out. That would leave me with y minus 6. My denominator is still y minus 6. The y minus 6's, they can cancel out, and I'm left with just a plain old 4. And that's that. All right, that was section 2.